Hi everyone. I have decided to combine chapters 10 and 11. They're pretty closely related and they start to get us into Unit 3, which talks about experimental design. So in this lesson, we'll talk about randomness and sample surveys. So first we might ask ourselves, why would we ever need randomness or want randomness within an experiment? And if you think about it, if you ask somebody to randomly select a number, there is also always going to be some reason that leads that person to pick that certain number. Okay, there's something inside of them that says, I'm going to pick the number 5 or whatever it is. Okay, so as humans, we are incapable of being truly random. So we randomize in an experiment to reduce any human-induced bias. Okay, so whether we admit it or not, there is some internal motivation to us selecting in the way that we do. Randomness ensures that we do not know the outcome prior to the experiment, and we may have an idea of what the outcome should be, but the experiment often leads to a different outcome than what we anticipate will happen. And we've talked about, or you have probably talked about hypotheses and that sort of thing back in science courses, kind of that same idea. We go into an experiment kind of wondering or kind of knowing what's going to happen, but then we do the experiment to see, is that right, is that incorrect? So randomness is really important. It takes away any human-induced bias that might otherwise occur. So if humans are not able to be random, we have to think of other ways where we can imitate randomness so that it is truly random. And the classic example is flipping a coin. This is a valid method of randomization because we don't know what the outcome of a single flip would be. One flip does not affect the outcome of another flip, so they're independent events, and it eliminates human influence in decision making. Now, unless you're really, really good at flipping a coin and you can project it in a way such that it lands on heads every time or something like that, this would be an example of a very solid 50-50 random situation. So when it comes to conducting an experiment, every study or experiment should have random assignment of treatments or random selection of a sample. So what do I mean by that? If we have, let's say, a experimental drug that we have and then a placebo, we want to randomly assign people to those treatments. We don't want to manually say, hey, you're going to take the pill, you're going to take the placebo. Also, when we are selecting who's going to participate in our study, we want to randomly select if it's ever possible. Okay, and we'll talk more in depth about why we want to do that. But in general, by randomly selecting your participants, that makes sure that your sample is representative of the entire population. Okay. So we talked about flipping a coin. What we're going to use primarily is computer or calculator functions. And in your calculator, you have a function, we'll talk about it in class, called random integer. So if you say rand int 1 to 2, it'll pick a number randomly from 1 to 2, or either 1 or 2. Now, when it comes to computers or calculators, it's not completely random. We call it pseudo-random. So it's not truly random. There's some sort of program behind it, but for our purposes, we'll consider it random enough. So if you think of some other ways that could be used to randomly assign or select subjects, we could draw cards out of a deck and then replace them. I don't know, I can't really think of any more. So think of some other methods of truly making a random selection. So experiments in themselves, you guys hear it all the time right now with COVID talk in terms of finding a vaccine. Experiments are great. They are real world. They work for the most part. But experiments also can be really costly. So you have to sometimes recruit people and pay them money. They can be time consuming, meaning you have to wait for an outcome to occur. And that's actually our biggest hang up now on COVID. So instead of doing an experiment, we can do what's called a simulation. And they are a cheap way to replace an experiment. So for example, let's say that a couple, they want to know how many babies need to be born before a son is born. Okay, so maybe that's their goal. They want to eventually have a son, and they want to know, using a simulation, on average, how many kids do they think they'll have to have before a son is born? So you can probably figure out why a simulation might be a better option here than an experiment. Of course, with an experiment, you're going to have to recruit a lot of people. They're going to have many, many children, and so it'll take 9 months per child. And then we would have to record until a boy is born, and it could just take a lot of time, okay? So in this case, simulation, much more efficient, much cheaper, better option here. So when it comes to a simulation, the first thing you want to do is identify what is it that we're trying to simulate, okay? So in this case, that is how many kids are born, or excuse me, how many kids before a son is born. So we're going to record how many kids were born before that boy came up. Then we want to explain how we're going to model our outcomes. Well, when it comes to children being born, in general, it's not perfectly 50-50, but we could say it's 50% male, 50% female in terms of babies being born. So maybe in our case, we're going to flip a coin. We'll say that heads is a male and tails is a female. Then we want to define what is a trial. So what ends a trial and what starts a new one. In this case, we could say we're going to flip a coin until we get tails, and then we're going to record that number of flips. So until a boy is born, we're just going to keep flipping and then record how many flips we had. Then we can state our response variable. So in this case, is it a boy or a girl? And then we want to run this trial many, many times. So the more trials you can run, the more accurate your estimate is going to be. So maybe in this situation, we're going to flip it for 10 trials. So we're going to go until we get a boy 10 times and then find the average maybe of those 10 trials. So then we can collect and summarize our data. So maybe in our case, the average number of flips among our 10 trials was 2.1. So we can state the conclusion that you would need to have about 2.1 children before a boy is born, okay? So obviously 2.1 doesn't make a lot of sense here, but based on our simulation, that's how we'd interpret it. So hopefully you can see why an experiment, while it is ideal, may not be the most efficient or cost-effective method to come up with an answer. So we'll talk a little bit about sampling and experimentation. We desire to know more about our population, which is the overall group of interest. So if I want to know about all US high schoolers, that would be my population. However, it is nearly impossible to survey everyone in a population. So what we have to do is settle for a sample, which is a subset of our population. So if you think about cooking is very similar to surveying or sampling, because when you want to just know how is this soup coming out, well, you don't drink the whole bowl of soup or eat the whole bowl of soup, you just take a little bit of it. So the goal is that within your sample, that sample is representative of your population as a whole. So one example of a sample survey where we survey just a part of our population is an opinion poll. And these are used oftentimes if you go to like a newspaper website, they'll have some sort of poll on there. But these sample surveys or opinion polls are used to learn more about an entire population based on a small sample's responses, okay? It is extremely important that our sample that we get our information from is representative of our population. Otherwise, our results are going to be misleading. So as a very brief example, if we want to know out of all the people in Fargo, North Dakota, what people's thoughts are on wearing a mask in public or something like that. Well, 50% of Fargo residents are male, 50% are female, but if within our sample we have like a 70-30 split, that may throw off our entire survey. So you want to really make sure that you have a well-representative sample of your population. So like I said, within our sample, we want to make sure that that is representative of our population as a whole. And if it's the case that it is not representative of our population as a whole, this is where bias comes into our study, okay? So sampling methods that tend to over or underemphasize some characteristics of the population, we say that is biased, okay? So the best way to avoid bias is to make sure that you're randomly sampling. And we'll talk a little bit more in depth about different sources of bias in a moment. One really quick note on randomization, why we would ever want randomness in our study. Randomness not only protects us from the differences in our population that we're aware of, so we know there are male and female, we know there are different ethnic groups, that sort of thing, but randomizing also helps us avoid things we aren't aware of. So if there's some other factor that we can't think of in our minds, randomness tends to even all that out within our sample, okay? So randomization makes sure that on average, our sample looks like the rest of our population, which is of course what we want in a sample. So you might be wondering, why wouldn't we just sample or survey everyone in our population? Ideally, yes, that would be what we would prefer to do. In this case, that is called a census. If you survey everyone in your population, that is called a census. You may have seen this past summer or fall, people in your neighborhood from the US Census Bureau trying to gather information from your family or from your neighbors. The US actually does this every 10 years. They actually record information from every single American household, okay? Now, an issue with that, of course, is that sometimes people aren't going to respond. People don't stay put, so by the time you collect their data, maybe they have moved, and ultimately it's just more time consuming and more complicated. So oftentimes a census doesn't really make a lot of sense. Let's talk a little bit about populations and parameters, okay? So first off, a parameter that is part of a model for a population is called a population parameter. So if you think about, if we took everyone in the United States and we found the average age of everyone in the US, if we found that true average age, that would be considered a parameter because that is a piece of information from our population, okay? Or if we found the range of ages in the United States, again, we know exactly for the population what that number is, so that would be considered a parameter. So population goes with parameter, okay? Some piece of information you get from your population, we'll call that a parameter. However, like we've seen already, it is very difficult to actually find what a parameter is because we can't survey everyone in our population. So what we do instead is we settle for what's called a statistic, okay? Statistics are from our sample, okay? So P and S, that's what we're dealing with here. Population, parameter, statistic is from your sample. So just keep that in mind when it comes to distinguishing between where our information is coming from. If a number is coming from our population, that's a parameter. And if we have a number coming from our sample, how we're estimating our parameter, that is called a statistic. So in general, this isn't always the case as you can see here, but in general, if we use a traditional letter like we use in our alphabet, that is going to be a statistic, okay? Whereas if we have a piece of information from our population, our parameter, that's going to be a Greek letter, okay? So in this case, if you look here, the mean, remember we had X bar before? X bar, that is the mean from our sample. That's a statistic. Whereas that Greek letter mu kind of looks like a U with a little curl on it. That is the population mean, okay? So X bar or Y bar in this case and mu mean exactly the same thing, except one is from our sample and one is from our population. So take a look at these. I'm not going to read all these off, but in general, if we have a Greek letter, it's going to be from our population. Let's talk a little bit about sampling in general. So of course we have our population. This is the group of people or things that we want to know more about. But we know it's very unlikely to actually sample that entire population. So we first start with what's called a sampling frame. Sampling frame includes any subjects that we could potentially have within our sample, okay? So for example, if I want to know more about people in the United States, the sampling frame, if my method is to gather data using the internet in some way, my sampling frame would include those who have internet. Now that doesn't mean I'm going to survey everyone in the US that has internet. That's not realistic. But because of my methods, that would kind of limit the sector of the population that could potentially be in my sample. So from that sampling frame, that's where we actually draw our sample from at random. So the first and most common type of sample that we have is called a simple random sample, and this is denoted with SRS, very common abbreviation for this. And like I said, this is a safe go-to for sampling in general. So what we do in a simple random sample is we number all of our subjects within our population of interest, then randomly select a desired number of subjects. And this will always lead to a representative sample. So if I want to know more about people at Fargo North High School, what I would do is number every student from 1 to about 1,000, whatever the actual number is. And then I would randomly select, maybe using a calculator, 100 of them. So I picked numbers 2, 860, 300, that sort of thing. They would be a part of my sample. So simple random sampling is always a safe go-to. There's never an issue with simple random sampling. We also have a sampling method called stratified sampling. And what I like to think of this as is sum from all, okay? And I'll explain that here in a moment. So when we analyze large groups, we often want to ensure that different segments of our population are presented, okay? And in this case, with a stratified sample, what we could do is divide populations into homogeneous groups that we can refer to as strata, okay? And from within each strata, we randomly select subjects. So for example, if we're going back to our Fargo North High School example, if that's our population of interest, one way that we could stratify our population is put all the freshmen into a group, then put all the sophomores in a group, then the juniors and the seniors, okay? So what we do, that's where that homogeneous grouping comes in. We put people into groups based on some characteristic that they have in common. In this case, it would be the level of grade that they're in, okay? And what we want to do when we do a stratified sample, after we put them into these groups, we want to randomly select some people from each of the groups. That's where the sum from all comes in. So we want some freshmen, we're going to randomly select from the freshmen. We want some sophomores, we're going to randomly select from the sophomores, and do the same thing for juniors and seniors. And that way, we can ensure that we have a balanced and well-represented sample. I have to warn you guys, stratified sampling is often mistaken for our next sampling method, which is called cluster sampling. Stratified, remember, that was sum from all. So we were taking some from each of our stratified groups. With cluster sampling, we are taking all from some of our groups. So not looking at all the groups, but we're going to take all from some of those groups, okay? And sometimes stratifying, as we saw in our last sampling method, it is not practical, takes a lot of time, it's a lot of configuring of your population. So what we do in a cluster sample is we first take naturally occurring clusters, and then we take all from some of those groups, okay? Let's think of it this way. Let's say we're interested in what the average GPA is at Fargo North High School, okay? Well, we could stratify by grade. We could put all the freshmen in, sophomores, juniors, seniors, but that's going to take a lot of time, okay? Especially if we're physically moving them to a room, okay? So what we would do in a cluster sample, maybe we would make our clusters based off of what class they're in during period 2, okay? So we're just going to let people sit in their period 2 class. That forms their cluster, okay? And in a cluster sampling method, what we do, instead of numbering people within our groups, what we do is we number the groups themselves, okay? So Mr. Lehman's period 2, that would be number 1. Mrs. Volk's period 2, that would be number 2. Mr. Wallen's period 2, that's number 3, and so on. You would number every single classroom for period 2. With a cluster sample, then we want to randomly select some of those classrooms, okay? So maybe we randomly select classroom number 1, classroom number 5, classroom number 8. All of the students within those 3 classes would be a part of our sample, okay? So instead of taking some from every single classroom, we are taking all the students from some of our classroom. So that is the difference between a stratified sample and a cluster sample. And if you think about it with a cluster sample, you could really get into some hot water here because, for example, if we're talking about GPA, and you happen to pick period 2 anatomy, period 2 AP Calc, and period 2 AP biology. Well, that is probably not very representative of our entire school population. So cluster sampling sometimes is not a very good option for that reason. If you're a visual person, this is maybe going to help you understand the difference between stratified and cluster sampling. On the left, we have stratified sampling. You see within each group, there is some similarity between the groups. So we have a red group, we have an orange group, green, and so on. So we are stratifying by color. And from those groups, we are randomly selecting some. So we're taking some from all of our groups. Whereas on the right side, we have very mixed groups, kind of naturally occurring groups. We're just kind of bunching them up. And instead of taking some from all of our groups, we are taking all subjects from 2 of our groups. So all from some. One other method we have is systematic sampling. And this is a very straightforward one to think about. If you think of like a conveyor belt, this is exactly what systematic sampling is. So before you start your sampling, this is where you take every 10th or every 20th person or subject, okay? So maybe you're going to line them up in alphabetical order, and you have decided I'm going to take every 15th person, and that's going to be a part of my sample. So typically, this is a really valid method of sampling, unless there's some quirky pattern that we didn't really expect to have happen. Like if we're talking about the student body, lining them up in alphabetical order, that probably wouldn't be an issue. But if there's some sort of defect in every 10th product or anything we're talking about, it could get you into a little bit of trouble. So just to finish up here, here's a little bit of vocabulary. First off, we talked about the population of interest. That is the group that we want to know more information about, okay? However, we can't survey the entire population most of the time, so we settle for a sampling frame. And these are the people we could potentially have as a part of our sample. The target sample, this is a new one. These are the individuals for whom you intend to measure responses. Now, you're not likely to get them all to respond, but that's kind of your target. That's the group that you hope to hear more from. And the sample, that is the actual group of people who respond to your survey. Now, we might have a project, I have yet to create it, but we might make a project of creating a survey, analyzing the results of that survey. So here are just some tips when it comes to creating a survey. So of course, you want to clearly understand what it is you want to know before you start to ask. So don't just throw something onto a survey before you really have a solid understanding of what you're after. Also, be critical of yourself. What could you improve within your survey before you send it out? Do the answers you receive answer the question of interest? So make sure that once you're analyzing your survey, make sure that they're actually answering the question you would hope for. You want to make sure you ask specific questions, and if at all possible, ask for quantitative results. That way you can find the average, you can do the mean, you can do the mode, all that good stuff. Quantitative data is just really good to work with. You want to be careful in how you phrase the questions, so we don't want to induce any bias into our surveys. And if possible, use choices, so like a multiple choice or a drop-down menu, instead of allowing free response. So we're going to see that there are a lot of types of bias that can occur in a study, just a handful of them. So voluntary response bias, that's where you allow people to choose whether or not they're going to be a part of our study, okay? So one really classic example is if you go to the Inforum website, they have a poll every day. That is voluntary. So if somebody's really passionate about that, whatever that happens to be, that question is about, they're probably more likely to answer that than if you don't really care that much about it, okay? Or if you don't know much about it. So voluntary response bias, those who are most passionate about it are probably going to respond, whereas the opposite people are not going to respond. We also have the idea of convenience sampling or convenience bias. This is where you just ask the people around you, you do what's easiest for you. So if I sit in my AP Stats class and I want to know what is the average GPA, and I only ask people in AP Stats, well, you people are stellar, so of course that's not going to be representative of the entire student body. Convenience sampling, never a good idea. Under coverage, that is when, for some reason, a portion of our population is not represented well in our sample. Okay, so maybe there's some sort of fear that they have by taking that survey. Maybe they think, oh man, they're gonna know information about me. I don't want to answer that. So under coverage, that's just when a portion of your population is not within your sampling frame. And then non-response bias, this is when a part of your sampling frame does not respond. Okay, and there are a lot of different types of bias. I mean, like the wording of a question leads to bias. Many of you have probably been a part of the bias project that I've done in the past. Whether we have time for that this year or not is another thing, but just be very skeptical when it comes to answering questions and also when you ask them.